First, let's do okay. Tonight we are going to talk about a study about algebra. Okay, I don't know how you feel about algebra. Have you had algebra before?
Yeah, well, not in this class, but in high school.
Okay, how did you do?
Well,
Oh, good. All right.
I really like math.
Oh, really? That's great. When we talk about algebra, as you can see on your PowerPoint, algebra is generalized form of arithmetic which uses letters, alphabet, called variable to represent numbers. So basically we have variables, constant refer symbols that refer to a specific quantity, and then when we put them together and use parentheses and use mathematical operation symbols between them, then it becomes an algebraic expression. Two algebraic expressions can join together by sign of equation. And in algebraic equation, basically we are trying to find the solution, the value for those variables which set them to be true. What do I mean? We evaluate an expression, meaning we want to find the values for those variables that make that expression to be true. Let's look at examples 1 through 3 at page 309. And here I want to stop this. Okay. For example, this here is an algebraic expression. We have variable x, we have constant 7, 5, exponential 3. We want to solve this when they told us the value of x is 6. All right? So we have, I put, instead of x, I put 6 here. So I get 7 plus 5 times 6 minus 4 to the power of 3. Have this also with me. Which is same as 7 plus okay, I think it's done. 7 plus 5. Now, inside the parentheses, 6 minus 4, 2 power of 3. 7 plus 5, 2 to the power of 3 is 8. So, you have to do here first before you make the addition, okay? So 7 plus 5 times 8, this is 40, so that's 47. So, when we say this algebraic expression for the value of x being 6, the answer is 47. We come here, this has two variables, x and y, and we have these constants. And then they tell us, let's solve this for x being equal to 4 and y equal to minus 2. So again, we put those values here, they get minus 2 times 4 to the power of 2 plus 5, 4 times minus 2 minus 2 to the power of 3. All right? So you get minus 2, 4 to the power of 2, 16. Sorry. Does it show that? Yeah. You can see that. What happened? That's not okay. Plus 5 times 4 times minus 2 is minus 8. Minus, no, 2 to the power of 3 is 8. You have a negative sign here. Negative times negative becomes positive, but positive times negative again negative. So we get minus 8. Right? So we get 2 times 16 minus 32 plus 5 times minus 8 well, let's just get minus times minus plus. So I get minus 40 minus 32. This becomes minus 72 plus 8. Then you subtract 8 from that, you get minus 64. Yeah. That's basically just plugging. All right. Yeah, we can see. Then we talked about, let's see, examples, other examples. For example, you can see it in your textbook. The other one, that was example number 3. So basically, we did that also. Now let's go to, again, let's go back to our PowerPoint and share the screen. All right. Terms of an algebraic expression are those parts that are separated by addition or subtraction or other operation. For example, we can rewrite, when we have 7x plus parenthesis minus 9y plus parenthesis minus 3, you can rewrite it as 7x minus 9y minus 3, or you can put parentheses. These are the terms, 7x minus 9y minus 3. These are 3 terms of this algebraic expression. These numbers here, 7, minus 9, these are coefficients for the x. The minus 3 is a constant. You may have, for example, we don't have it here, the coefficient of, for example, if you can have just an x, the coefficient is 1, okay? And the numerical term is minus 3, or a constant, or actually just 3. The operations just separates it, okay? Let's go. The parts of each term that are multiplied are called the factors of the term. For example, when we have 7x, the factors are 7 and x. Then like terms are terms that have the same variable factors. Like 3x and 7x are like terms. I'm not saying that they are identical, but they are like terms. They have a coefficient and they have a variable. All right? We can combine like terms. We can use the distributive property of real number on page 312. You can review that. And you can simplify. You should simplify an algebraic expression when the parentheses are removed and you go to basically to its simplest form. For example, let's look at, let's go to page 314. And if you just, let's look at that table on page 312. It is commutative property, associative property, distributive property. It's good to remember that. A plus B is the same as B plus A. Example, 13 times x to the power of 2 plus 7x is the same as 7x plus 13 times x to the power of 2. Or distributive property is very important. If you have A times parentheses B plus C, it's the same as AB plus AC. All right? It says, let's look at something in here. All right. For example, on page 315, or let me, let's go here. Let's look at, for example, on let's look at number 39 on page 314 on set exercise set 6.1. For example, you have 7 you have 7 plus 2 parentheses x plus 9. The law of distributive. This is the same as 7 plus 2x plus 18. Yes? Yep. Because this goes here and not one. Therefore, I can write that. I can move things around. I can write that 2x. And so this 7 plus 18, 25. So this whole thing here is equal to that. Right? Or let's look at, for example, on page 315. We have number 41. It tells us to simplify that. We have 7x plus 10x. Okay. What if I want to simplify? What would be the answer?
It would be 7x.
Yeah, exactly. We have 7 of x and we have 10 of x, so just add. Or let's say you have number 62. We have 7x minus 4, and then we have the brackets. 6 minus parentheses 8 minus 5x. Okay? So, start from inside here first. So this would be 6 minus times 8 minus 8 minus times minus plus 5. So just first for now, just let's work on here. 6 plus 6 minus 8 minus 2 plus 5x. Okay. And I have 4 back here, and I have 7x here. So I can go up here. I have 4 times 2, minus 4 times minus 2. I have 7x. Then I have minus 4 times minus 2 plus 8. Yes? Minus 4 times plus 5x would be 20x. So I have minus 20x and I have plus 7x. Becomes minus 13x plus, yeah, that's as far as you can go. All right. X, 4. Good. Okay. All right. Any question? Nope. Oh, I wonder. This is not focusing. I hope there's nothing wrong. All right. Let's move on. Okay. Because now we want to solve linear equation. We call this linear because x is to the power of 1. Okay? You don't, if you have any variable that has a power more than 1, then it's not linear. And if it's power of 1, it means we call it linear. That means if you draw it on a graph, it would be a straight line. But whenever you have power of 2 or whatever else, then you have curvature. Okay, the linear equation in one variable, you can have more than one. It would be this form: ax plus b equal to 0 when a is not 0. And those addition, multiplication properties, still you can use them to solve linear equation. I think page 318 is basically a summary of that. Yeah, if you go to your textbook on page 318, for example, A is equal to B if you add on that table, on that middle of the page, if you add C to both parts, they're equivalent because you're adding the same variables, the same amount to both sides. If A is equal to B, if you multiply both sides by C, then they're equivalent. It says, the textbook says, as long as C is not 0. But even if it's C is 0, it would be equivalent because 0, it makes both sides 0. 0 is equal to 0. You know, like the table 6.1, x minus 3 is equal to 8. In order to solve it, you just add plus 3 to both sides. Minus 3 is canceled, x equal to 11. And like the last one, x over 5 is equal to 9. Multiply both sides by 5, x equal to 45. I think these are very straightforward. To solve the linear equation, you simplify algebraic expression on each side, removing grouping symbols, combining like terms. You collect the variable terms on one side, all the constant numerical terms on the other side. You isolate the variable and then you solve. Then you can check your solution by putting that answer back in that equation. For example, here it tells us, look at page 328. Page 328, exercise set 6.2. let's, for example, do number 14. Start simple. You see that? Number 14. Okay. It says 3x plus a is equal to 50. 3x plus a equal to 50. I have to change the structure. Yeah. I can move this. I move this to the other side by adding, actually, I get rid of this by, or move it to the other side by adding minus 8 to both sides. These two are canceled, so I get 3x is equal to 50 minus 8, 42. Divide both sides by 3. See, I can do these things because I'm not changing the expression. I'm doing the same thing to both sides. That's the key. These 3 cancels. So the x is equal to 42 divided by 3, which would be 14. Yeah. Let's do, for example, number 31. Can they see it? Yeah, they can see that. Okay. We have third one, 8y minus 3 is equal to 11y plus 9. Okay? So we said when we want to solve a linear equation, bring all the variables to one side, all the constant numbers to another side. I want to bring this to this side. So minus 11y minus 11y. I want to take minus 3 to that side. In other words, I want to get rid of it. So plus 3 plus 3. These two cancel, and these two cancel. So I have minus 11y plus 8y makes it minus 3y is equal to 9 plus 3, 12. So I divide both sides by minus 3. These cancels, so y is equal to minus 4. And to test if you put that back into this equation, it should hold. If you put minus 4 here, we get minus 32 plus minus 3, so we get minus 35. If we put minus 4 here, we get minus 44. Plus 9 would become minus 30. So it's okay. Let's go moving. All right, the cross products principle for propulsion also apply. If we have A over B, as you can see in your PowerPoint, is equal to C over D, then A, take this multiplied by D, these two sides. AD is equal to BC, okay? You follow me? Yep. All right. The cross product AD and BC are equal. Let's look at an example on page 325. First time what?
I think it's the first time.
Yeah. That makes things very simple. A over B is equal to C over D. Then AD, take those two sides, multiply them, is equal to times BC. Look at example 7 on page 325. 63 over x is equal to 7 over 5. Therefore, if we have 63 over x equal to 7 over 5, apply that rule. Meaning, not in the book is trying to show you, it's going through all the steps, but basically this, take these two, multiply them by together, 63 times 5, is equal to, take these two, 7x. So that's the simple thing to do. 60 times 5 would be 315 is equal to 7x. Divide both sides by 7. These two cancels. So we get x is equal to 315 divided by 7, 45. Okay. So just these two multiply this time that is equal to this time. When you have this kind of fraction, if I had plus 1, it wouldn't work. Okay. Right. Let's look at something on page 329. For example, yeah. Look at number 64. All right. Would you like to do it?
64?
Yeah, over here.
Sure.
Okay. Let me see. Yeah, let me go over this because it wasn't a. So we have 63 over x equals 7 over 5. Just multiply this times that is equal to 7 over x. 63 times 5 is 315, 7x. We divide both sides by 7. X is equal to 45. I was just saying, if we had, for example, plus 1 here, this thing wouldn't work. This simple way is only works when you have a over b equal to c over b. Then AB is equal to BC. Would you like to do the other one? Yes. Here we go.
64 is that?
Yeah, let's do 64.
So
On page
64
329. Is minus 3 over 8 over 8 equal to 6 over 8. 6.
Oh, sorry. 6 over
X.
So that would be minus 3 times x equals 8 times 6. So that's equal to minus 3 x.
Equal, yeah. Equal to
8 times.
Or 3.
8 times 6 or 8.
Okay, and then what you do?
And then we continue solving the equation. So we divide or eliminate 3.
Yeah, divide both sides by minus.
My box. So can I do it here? Sure. So divided by 3. So what's here? One number remains. And x. Very, yeah, you're right.
Plus or
Right. Sorry,
That's
minus 6.
That's it.
Minus 3.
Yeah. Okay. Simple. Yeah. Sure. All right. Let's move on. Then we want algebraic translation of English phrases you have on page 332. Let's look at that. Let's see what they're talking about. This is helpful for turning a word question into an algebraic expression to solve. For example, when it talks about, if you look at that table, 6.2, the sum of number and 7, so sum of any number, so you have a variable, unknown variable, x plus 7. 5 more than a number, or a number plus 5 would be x plus 5. A number increased by 6, x plus 6. You follow?
Yeah.
Okay. Subtraction, a number minus 4, x minus 4. A number decreased by 5, x minus 5. 9 fewer than a number. So you have a number, x, but you want to go 9 whatever fewer than that number. So you have x minus 9. Let's look at this one. The difference between a number, whatever number, and 6 is x minus 6. You follow? Multiplication. 5 times a number, 5x. 2/3 of a number, 2 over 3 times x. 75% of a number, used with decimals. So you have, remember, you can write 75% as a decimal. You write 75 divided by 100. Then you have 2 zeros, so it becomes 0.75 times x. Let's look at, for example, that big one done at the bottom, more than one operation. So we have 25% of sum of 3 times a number and a 14. So, okay, if I want, you have a word expression in English, we want to translate that into algebraic expression. It says 3 times a number. So I need to have 3x. Okay, you see that?
Yep.
Then I say 3 times a number and 14. So I have 3x plus 14. Then it says, so you have the sum of these two, 3x plus 14, 25% of it. So multiply 25%, which is 0.25 times the parenthesis 3x plus 14. But if you follow, it's not that hard. If you look at it, starts where it says 25% of, so I need to get 25% of something. What? Of the sum of 3 times a number, 3x plus 14. All right? 7 times the sum of a number and 24. So I have a variable, I don't know what that number is. I call it x. The sum of x and 24, so I have x plus 24. 7 times that, so I need to put the 7x plus 24 in a parenthesis times 7. follow?
I think so.
Okay. Basically, when we want to solve word problems, you read the problem carefully, at least twice, to make sure you understand. If you can even sketch that problem to visualize it, then find out what are you looking for? What is it that you're trying to find? What is that unknown quantity? And represent that with a letter. Usually we use X. Then write the word problem as an equation. Solve it for X. Then check your answer by putting it back in that solution. For example, let's look at some of these, not all of them, but some of them. On page 333, I'm not going to write it on the board. If you could just follow on the PowerPoint and your textbook. Page 333, example number 1. It talks about, you see that? Okay. It shows a graph of average yearly earnings in the United States by highest educational attainment. You know, if you have less than 9th grade, some high school education, high school graduate, some college, if you have associate degree, or if you have a bachelor degree. And it makes the graph representation for male and female. And unfortunately, usually females, even with the same level of education, get lesser income, lesser earning. We want to find the average, okay, now let's read the question before we do anything. Let's first find out what we are trying to find. The average yearly salary of a man with an associate degree exceeds that of a woman with some college by $3,000. The average yearly salary of a man with bachelor degree or more exceeds that of a man with some college by $41,000. Combine 3 men with each of these educational attainment earn $188,000. Find the average yearly salary of a man with each of these levels of education. What levels of education? We look at here in this word problem, it talks about people who have a bachelor degree, people who have associate degree, and people who have some college. We want to find the average salary of men for these 3 levels. Okay, so we know what this is, helps us to find what we are looking for. We start with the lowest, because if you find the lowest, then you add those extra income that the word problem tells you, you find the others. The lowest that in this question is asking us, what's the lowest one? No, I'm not talking about what kind of men, what kind of college degree we are.
Sorry.
Some college, exactly. So we are looking for some college, associate degree, and a bachelor degree for men. We call the lowest X the average yearly salary of a man with some college in thousands of dollars. The problem tells us that a man with the associate, man with some college. So the second level is only X plus 3. You see, I'm not going to write it with another variable because then it becomes too complicated. You want to keep it at one variable, the other unknown, just write it in relationship to that, because it says if X is an average yearly income of a man with some college degree, a man with associate degree gets $3,000 more. So if I call the first one X, the second one would be X plus 3,000, or let's just say 3 in 1,000, X plus 3. And then a bachelor degree, how do we express that? It says here, the average yearly salary of a man with a bachelor degree or more exceed that of a man with some college by 41,000. So the other level, if I want to write it, it would be x plus 41. Okay? Now, we want to find the average yearly income for all these three levels. So it tells us, it gives us one more piece of information. It says if you combine these three men with each of these educational attainment, some college, associate degree, and a bachelor degree, it adds up to 1,800. Okay? So it tells me if I add x, a person with some college, plus x plus 3, a person with an associate degree, plus x plus 41, a man with a bachelor degree, I will get $188,000. Then I can solve this. Now I have translated a word problem in English to mathematics, to an algebraic expression. X plus 3 plus parentheses x plus 41 is equal to 188. You just, because it's just parentheses, there is no multiplication, just remove parentheses. 3x plus 44 is 188. Divide both sides by 3, x is 48. So the average yearly income of a man with some college degree would be 48,000. With a bachelor degree would be 51,000. Okay, with an associate degree. With a bachelor degree would be at 89,000. Okay, so we find all those three. And in order to check it, add 48 plus 51 plus 89, you get 188. That's a very good word problem. All right. Let me see. Let's look at another one on page 336 of your textbook. Example number 4. Okay, why don't you read the problem for me?
So, example number 4 says, your local computer store is having a terrific sale on digital cameras. After a 40% price reduction, you purchase a digital camera for $276. What was the camera's price before the reduction?
Okay, so you see here, it's telling us that the discount rate is 40%. After that discount rate, after that's taking off that sale price, after that discount rate, the price is $276. We want to find the price of this digital camera before the sale, before the discount was taken out. So what is it that we are looking for? The original price. Let's call the original price X. Then it tells us if you have the original price, take out the discount. What is the discount? 40% of what? Of X, of original, yeah? So, right, so we have X minus 0.4X. That's how much we are taking out. Okay? It says, when you do that, your final price is 276. So I have translated, again, a word problem in English to an algebraic expression. X, the original price, minus that discount amount, which is 40%. 40% of what? Of the original price. So you multiply the original price, X, by 40%, which is 0.4. You follow me?
Yeah.
Okay. So that should be equal to 76. So we basically solve this algebraic expression. x minus 0.4x is 0.6x equal to 276. Divide both sides by 0.6, x is equal to 460. So the original price, and you can check it, the original price was 460. 40% of that is 184. If you subtract 460 minus 184, you get 276. All right?
That's expensive camera.
Yeah, yeah. That's a good deal that you get 40%. It's almost half. Let me see. All right, let's move on. The others are basic, this, same principle. I just wanted to make sure we cover everything enough time. Now we come to inequalities. You see, all these things, you have that equal sign. You can also have inequalities. How do you do that? It's the same process. Basically, solving for an inequality is a process of finding a set of numbers that makes that inequality true. Okay, those numbers are called solutions that satisfy that inequality. And if you have, usually you have more than one answer, then you have solution set. Okay. Here, let's first talk about graphing them. Graphing linear inequality in one variable. Let's look at page 342, 43. For example, the table 6.3. So we are at page 342, the bottom of the page, table 6.3. It says we are using the set builder notation. For all x, which x is less than a. So if you have a number line, and notice it doesn't say less than equal, it only says less than. So I put an empty circle on a. All numbers less than a. From there, then a solid line goes to forever, infinity negative. Now notice the second one, less than or equal to a. Now notice on that picture, on that graph, that little dot is a solid dot.
Right.
X greater than b, but it doesn't say equal to b. So you have the empty dot going all the way to plus infinity. Greater than or equal, so then it becomes a solid dot. Now, all x between greater than a, less than b. So you see that graph, a and b, the between them is a solid line, but both points a and b are empty dots. If they were equal, then you make it solid dots. Or if one of them just didn't have the equal sign, you make that one just empty. Example, let's, for example, look at some of these examples here. Example 1, let's look at A. Can you read me what does it says?
Yes, A says x.
For all x.
So, okay, so do you read it like in the example like here?
You say for all x, which are a real number, less than number 3.
So for x is a real number less than 3.
Okay. So if you want to graph that on a number line, you see right there in front of it, you have 0, 1, 2, 3, 4 going to plus infinity, minus 1, minus 2, minus 3, minus 4 going to negative infinity. You see that it says all the real number less than 3. So on number 3, the numerical value 3, I put an empty circle. Then I have a solid line that goes to negative infinity and just keeps going. I just put an arrow, okay, a pointer. The second one, number B, for all x, where x is a real number greater than or equal to -1. So on the number line, I find -1. Should I make it an empty or solid? Solid dot. Why?
Because it's equal.
Yeah, I have it equal. And it says greater than or equal. So I go this way. I go to the right to positive infinity. Look at number C. You have the number line for all x, where x is a real number. We want all the values for x, which is greater than -1 but not equal, but less than or equal to 3. So then I find -1, I put an empty dot, and I find 3, I put a solid dot, then I draw a solid line between them. It talks about those numbers greater than -1, but less than or equal to 3. All right? Let's keep moving. Any question?
No.
No. All right. Now, when we want to solve linear inequalities, you do the same thing as, let's say you're doing an equation, except if you multiply or divide the inequality by a negative number, then just reverse the direction of that inequality. If it says, for example, less than 3, but you're going to multiply both sides by a negative number, then change that to greater than 3. Same for a division. Just treat it as an equal sign, except if you're multiplying or dividing by a negative number, just reverse that direction of inequality. Let's look at some example again from our textbook. Let's go to page 344, example 2. It tells us, solve and graph the solution set 4x minus 7 for all x which are greater than or equal to 5. Okay? Now, please just follow from your textbook, all the online student. So you have 4x minus 7 greater than equal to 5, all right? Just treat it as if that was an equal sign. I add plus 7 to both sides. I'm not going to change the inequality sign because I'm not doing any the multiplication or division by negative. So I add plus 7 so to get rid of that minus 7. So I get 4x greater than equal to 12. Now I divide both sides by 4, so I end up having this inequality is true for all x greater than or equal to 3. And I do not change the direction of inequality because I didn't do anything with negative. I didn't multiply by negative or divide by negative. So when I want to graph it, you go on the number line, you find 3, I put a solid dot, why? Because it says equal. And then solid line going to positive infinity. Let's look at, for example, on example 3 on page 345. It says 1/3 times x, 1/3 of x less than 5. So in other words, it tells us, find all the numbers, all the real numbers for x where this inequality holds. So what do? I multiply both sides by 3. You see that? This is on page 345 of your textbook. Example 3, number A. So I multiply both sides by 3. So I get rid of that 1/3. I will have x is less than 15. Right? 5 times 3 is 15. So you go to the number line and you will have, you find number 15 Should I put a solid or empty dot? Why? Negative. So put, and then you just solid line all the way to negative infinity. It tells you if you put any number, let's put 10, just check. 10 over 3 is about 3.3333 is less than 5. For any number less than 5, that inequality holds. For any number less than 15, that inequality holds. See that? All right. Now, let's do number B. Number B is minus 3x less than 21. Why don't you do that? Can you do it on the board?
Number B?
Yeah. And, let me just stop share. We want to erase the other stuff so it'll be more clear.
Should I erase everything?
Yeah, yeah. And if you want, you want this? Why don't you use this one?
Yeah.
So I can read it for you.
There.
We have minus 3x less than 21.
This one is dry as well.
Oh, it's dry. I'm sorry. How about
Open it here.
yeah? How about this one?
Minus 3.
Minus 3x.
This one too.
Oh boy,
Wasn't right.
I have to bring my own set.
Minus 3.
Okay,
Again, 3.
minus 3x less than 21. Okay, how would you solve this inequality?
So, first of all, we will get rid of number 3. So we do that by dividing both quantities by minus 3.
That's right.
So 3 eliminates itself, and we end by x minus to negative 7.
Okay, but you just divided both sides by a negative number.
Right.
What should you do with that sign of inequality?
Without sign inequality.
Reverse it. Instead of less than minus 7, now you should become greater than minus 7.
Greater than minus. Oh, okay.
So the answer, just you can just erase it with your finger.
Okay, here.
Yeah.
And goes out the way.
Yeah, that way. So that's the answer. For all x greater than minus 7, that inequality holds. For example, try put minus 6.
Minus 6?
Yeah.
So are you going to solve it?
Yeah, just if x is minus 6, see whether that holds. Minus 3 times minus 6
plus 18
is less than 21. Therefore, that's true.
All right.
That inequality holds. You can try it as long as you want. It holds.
Okay.
So you have to remember, reverse when you divide or multiply by a negative number, reverse the sign of inequality.
Okay.
If it's less than, make it bigger. If it's bigger, make it less than.
Okay.
All right. Thank you. Okay.
Oh, I think they're not able to see it.
No, it is. They are. Okay. Let's go to page 346. Okay. On page 346, example 5. That's a good one to see how it works. It tells us solve this linear inequality and then graph it. So we have 2 times parentheses x minus 3 plus 5x less than or equal to 8 times x minus 1. All right? maybe let me do it on the board, because that would be a good one to see for people. So, all right. Can you read me the solution, the problem?
Yes, the problem is 2. How do you? Because it's like times.
Yeah, you just read 2 times 2 parentheses x minus 3.
Oh, 2 parentheses x minus 3 plus 5x. It's less or equal to 8 parentheses x minus 1.
X minus 1. That's it?
That's it.
Oh. First, just I think this is a positive plus, equals. So I just multiply 2 by here, 2 by here. I get 2x minus 6 plus 5x less than or equal to 8x minus 8. Okay. 2x plus 5x, I have 7x minus 6 less than or equal 8x minus. So I want to bring all the x to one side. Again, I'm not multiplying or dividing. I can subtract minus x. So these two cancel. So I get I have 7x minus 8x, get minus 1 minus 6. Okay, less than or equal minus 8. I didn't change this direction because I didn't multiply or divide. Okay. Now I want to take this number over there, so I add plus 6 to both sides. You get minus x. These two cancel, less than or equal, plus 6 minus 8 minus 3. Okay. Now I want x. So I'll multiply both sides by negative. But once I do that, I have to reverse the sign. So this becomes plus x greater than or equal to 2. For all numbers greater than or equal to 2, this inequality holds. Let's check it. If I have another color. If I put, for example, 3, let's say x is equal to 3. If x is 3, 3 minus 3, 0, so this becomes 0. 5 times 3 is 15. So if x is 3, this becomes 2. 2 times 8 is 16. 15 is less than 16. Then to graph it on the number line, so we are saying for all numbers greater than or equal to 2. So if you have a number line, 0, here is minus 1, minus 2, 1, 2, 3, 4, so on. I go to 2, and I make a solid dot because it has equal, and I go all the way. For all numbers greater than or equal to 2, this inequality. All right? Okay. Let's look at that's a good one too. Right? See if I have it. Okay. Why don't you do example 6 on page 347?
step?
Yeah, I will read it for you. You can use these two if you want. But first, let me erase this. Okay, here we go. All right. Let me make sure. One moment, sorry. I think we are recording. Okay, all right. Let me read it for you. So it says solve and graph solution set for this. -3 less than 2x plus 1 less than or equal to 3.
Less than or equal to 3. So there are two inequalities?
Yeah.
Oh, wow. Okay.
So you want to have x in the middle. So first get rid of that plus 1.
So that plus 1 goes that way, right?
Okay. So but you have to remember, whatever you do, you have to do it to the whole inequality.
So in this case, okay. So we have minus. Oh, yeah. Or we can just like delete it by subtracting 1 from here and 1 from here.
Yeah.
So we end
and
from
1.
here too?
Yeah.
Oh.
And the whole thing.
Okay, because there's
You can't. If you're doing anything, you got to do it to the whole set, to the whole equation.
Okay.
So you get
by -4 less than 2x, which is less than
or equal.
or equal to 2.
Okay. Now you have to get rid of that that coefficient 2 for x.
So we divide it by 2.
All right.
And we end with -2. It's less than x, which is less than or equal to 1.
That's right. That's it. You got the answer. So if you want to graph it, so it tells you that inequality holds for all value of x that are greater than -2 but less than or equal to +1.
So let's see. So we have a graph here. And here is 0. So -2 would be here, but it's not a solid circle.
That's right.
And it goes all the way to to 1, but it's a solid circle.
Because that's an equal sign.
Because it's an equal.
So then
where should we?
Just between those two.
Yeah, those between these 2 points, right?
Yeah. All the numbers between these two.
All the numbers.
For all the numbers between these two equal to 1, that inequality holds. All right. That's it. Thank you. Thanks. All right. Let's move on. Okay. Let's keep moving. I think you guys got the idea. Let me just check something. Sure. Yeah. You want a break? No? You're okay? All right, we come to quadratic equation, multiplying two binomial using FOIL method. It's just basically a plus b parentheses times c plus d, as you can see in the PowerPoint. It's equal, you take a, which is the first or the outer, times c, and a times d. Again, then b, the inner, b times c, and b times d. Simple. A binomial is simplified algebraic expression that contains two terms in which each exponent that appears on a variable is a whole number. Let's look at pages 351, 352, examples 1 and 2. For example, that's where we get the abbreviation FOIL. First term, outside term, inside term, and the last term. So we have x plus 3 parentheses times x plus 4. In order to solve that, x from the first parenthesis gets multiplied by x from the second parenthesis. You see that on your textbook? Yep. And so we get x2, x times 4, we get 4x. We get 3 times x, 3x, and 3 times 4, 12. So you get x2 plus 4x plus 3x plus 12. 3x, 4x, and 3x, you add them, you get 7x. That's the answer. The other one, example 2, 3x plus 4 times parentheses 5x minus 3. Again, let me do that on the board. Just make sure people understand. Okay. We have 3x plus 4, 5x minus 3. So I take this times that, and then say 3x times this one. 3x times 5x, 15x2, correct? 3x times minus 3 minus 9x. Okay? Then I take this one, multiply it by here, and multiply it by here. So I get 4 times plus 5x, 20x. 4 times minus 3, minus 12. So I have 15x2 minus 9x plus 20x is plus 11x. Minus 12. That's it. Yep. All right. All right. Okay. Basically, the FOIL method, as you can see on the PowerPoint, you have a plus d parentheses times c plus d. You take the first, the letter f comes from there, a times c, then a times d, times the first times the outer, then the inner I, b times c, b times the last, b times d. All right? Okay. What? Any question?
No.
Okay. Now, this is important for factoring a simple trinomial. Trinomial is simplified algebraic expression that contain 3 terms in which all the variables have whole number exponent. When we want to factor, We want to factoring is an algebraic expression containing some or different term, means finding an equivalent expression that is a product. For example, if you have a trinomial form here, minus x2 minus 7x minus 12, to make it in a factor term, so you want to, you're doing the reverse. You want to go back to those two parentheses form. So you want to find, for example, how can I write this in that two parentheses form, which would be x plus 3 times x plus 4 with a negative 1 over here. You follow? All right. Okay. It's basically x2 plus bx plus c we want to factor. Let's look at, for example, page 352 of your textbook. You have, okay, basically you want to find two parentheses with an x as a variable, and you need to have two numbers that will make it equal to that x2 plus bx plus c. Okay, let's, for example, if I have x2, look at example 3. That I think that will make it more clear. I have x2 plus 6x plus 8. Let me go to the board. I have x2 plus 6x plus 8. x2 plus 6x plus 8. So I want to go back in reverse of it's a reverse of the form. Okay, to those two parentheses form. So I need to have x and x to get x2. And the coefficient is 1, so I don't need any numbers. So I'm looking for two numbers, which when I multiply them, I get 8. Multiply them, I get 8. When I add them, I get 6. So what do you think? What are my choices? Well, 6 can be 3 times 2. But yeah. So 2 and 4. 2 and 4. It works. So let's see about their sign. What kind of sign they should have. This is positive, and this is positive. So both of them plus. And if I check it, x times x, x2, x times 4, 4x, 2 times x, 2x, 2 times 4, 8. And these two become 6x. So I get back to the original question. All right? So you ask yourself, what are the two numbers? When they are multiplied, it gives you this number. And when you add them, it gives you this number. Keep in mind the sign. All right. Okay. Okay. You're on page 352. Example 3. Page 354. Okay, let's look at page 354 of your textbook and look at example 5. It says factor 3x2. Now, notice it has a coefficient minus 2x plus 2.8. So if I want to write it as two parentheses, as you can see it on your textbook, step number 1, you write two parentheses, but now you need to put 3 before one of those x's. Okay. Now, you want to find the two numbers that when you multiply, you get 28. When you add, you get 20. So you can have all kind of possible choices. If you use none. The thing is this, here, because we have coefficient 3, that changes everything. It's not that simple. It's not that simple of just find two numbers that you multiply 28 and add them becomes 20. You just try different, but we know that if we multiply them, they should become 28. So we try different things. If I use 28 and 1, but when I add, I end up with 84x minus 1x, I get 85x, so that doesn't work. If I use minus 28, bring the minus 28 this way, minus 1 over there, again, doesn't work. If I use minus 2, minus 14, still doesn't work. The only choice that we'll have is to have minus 14 in the first parenthesis and minus 2 in the second parenthesis. Then you end up having minus 14x and also minus 6x. When you add them, you get minus 20x. You get that middle term. Okay?
So you just
sometimes you just have to try. But it's not unlimited because you know the product should become 28. So you just see what numbers will give me, what two numbers gives me 28, and also plug them into those two parentheses because I have that coefficient of 3. At the same time, I end up having minus 20x. You follow me?
yeah.
Okay. Let's look at, for example, example number 6. Why don't you do it on the board? So it will help. Get erase them if you want here. Okay. I will read it for you. 8y2, 8y to power of 2.
Power of 2?
Yeah. Minus 10y minus 3. So first,
Minus 3?
yeah. First write two parentheses.
Right. Where should I put it here?
Doesn't matter, yeah. You want y and y. And you also notice you will need to have, you want to have, one of them has to have, you want to have 8y2. So either you will have 8y, 8y in one parenthesis,
Right.
and 1y in the other, or 4y and 2y in the other parenthesis.
Try 2 and 4.
Okay. Basically, what you will end up, you see, you can see it on here. You see it on the page 355 on the table.
Mm-hmm.
It gives you, it takes each of them. The first one, 8y and y, and then 4y and 2. And for each of them, it tries these two numbers that, you know, the multiplication you want to have, the product should equal to, you want the sum of the outside and inside product should be equal to 10y.
Mm-hmm.
So it just tries them. You
Right.
know, it puts 8y plus 1, y minus 3, it tries this one, it tries this one, it tries this one. This is the only one that works. 4y plus 1, 2y minus 3.
Minus 3. Yeah.
Why don't you do that? 4y plus 1, put a plus 1 for that.
For
Yeah.
which one?
Yeah, that parenthesis, plus 1.
This one is plus 1?
Yeah.
Okay.
And then
This one is
and then and 2y minus 3. Okay. Now, why don't you do that FOIL method? Multiply.
All right. So, according to the FOIL,
okay. 2y times 4y.
Should I put the?
No, just multiply.
Okay. So 2 times 4 is 8y.
2y times 1.
1 is
2
plus, or 2y. And then we go and move to this third. So it's negative or minus 3 times 4 is minus 12y. 12y and minus 3 times 1 is
minus
3.
Okay. Then.
So we can solve this and we end up with minus 10y. So it's the
so you see the thing that helps you to realize you want two numbers with correct signs that this makes the sum of the y equal to that middle one and their own products equal to the last one. So it tells me, right there that, I want some kind of a product of something that gives me minus 3. And then I have to, but I also have this 8y2. So that's the thing that makes things a little bit tricky. And I have to try different numbers.
Right. There's no other way.
Yeah. Okay. Thank you.
Yeah.
All right. All right, let's move on. Quadratic equations this is called quadratic equation. You have a x to the power of 2b times x plus c equal to 0 when a, b, and c are a real number. A is not 0. We want to solve quadratic equation by factoring. All the things that we just said comes handy here. Like example 8 of your textbook, 356. You have x2 minus 2x equal to 35. We want to solve this. So you have to make it to look like ax2 plus bx plus c. Okay? So I have to bring 35 to the other side. So I subtract 35 from both sides. I get x2 minus 2x minus 35 equal to 0. I write 2 parentheses. Fortunately, the x2 doesn't have any coefficient. So it's x and x, two numbers that are multiplied gives me 35. And when you minus 35, when you add them, you get minus 2. So it's 7 and 5, and it has to be minus 7 because when I add them together, minus 7 plus 5, when I add them together, I get minus 2. That's how you solve it. And then, you see, if I want to go one step further, to solve this equation, it means that this equation can be true for two values of x. X minus 7 equal to 0 and x plus 5 equal to 0. If x minus 7 is equal to 0, x is 7. You follow me? Yeah. And if x plus 5 is equal to 0, then x is minus 5. For two values, minus 5 and 7, that quadratic equation holds. I have two values because the highest exponent of my variable is 2. If I had x to the power of 3, I need to have 3 answers. Okay? You follow what I did? You can see that on page 357, step 5. Basically, what they have done is they made, they try to, they say, let's check it, and They say, for, you know, or actually a step 3 and 4, they say x minus 7 equal to 0, therefore x is 7. If x plus 5 is equal to 0, then x is minus 5.
Yep.
All right. Or let's look at example number 9 on page 357. 5x2 minus 6x, I'm sorry, 5x2 minus 33x plus 40 equal to 0. Again, I write two parentheses. I need to have x, and I need to have one of them. 5 has only, it's a prime number, so it's only 5 and 1. So I get 5x and x. Now, here comes that tricky part, factoring them. You want to have the product to be 40. So I know it has to be some kind of the something that two numbers that when I multiply them, I get 40. And at the same time, you need to have, when you add them together, you get that middle term, 33x minus 33x. But that 5 makes things a little bit tricky. So you can, but if you try, again, with different numbers, but remembering that you're looking for a product of 40, you end up having 8 and 5, minus 8 minus 5. And it means that for 5x minus 8 equal to 0, so x should be 8 over 5, or x should be 5. For these two values, that quadratic equation is true. Or the answer for this quadratic equation are x equal to 8 over 5 or x equal to 5. You understand what I mean? Okay. Yeah. You see, you make each of those parentheses equal to 0 and solve it for x. All right? Let's move on. Sometimes, you know, the thing that helps to find when it's really difficult to factor, we use this quadratic equation or quadratic formula that x is equal minus b plus and minus the square root of b2 minus 4ac divided by 2a, where a is not 0. Like, let's look at page 358 in your textbook, example number 10. You know, that formula helps because it helps you to save time instead of trying to do all those trial and error. This is the key. That's this formula. Yeah. So here it is, but it's good to know it so you know how this formula works. You have 2x2 plus 9x minus 5 equal to 0. So my a is 2, my b is 9, my c is minus 5. Keep that in mind. That's our formula, quadratic formula. Plugging the values for b, a, and c. You just plug in, and square root of 121 is 11, and the final answer is x should be minus 9 plus and negative 11 over 4. So x is either 1/2 or minus 5. So that's the answer. Instead of trying to do all that trial, you got to memorize this formula. All right. Okay, I think this quadratic formula helps a lot. Graph and function. It's, you know, this is something very easy. Let me just show you. This is basically called Cartesian system. You know, slide number 26 on your PowerPoint. We have x-axis, y-axis. X is a horizontal, y-axis is a vertical. Then we have 4 quadrants. It goes counterclockwise. Quadrant number 1, quadrant number 2, quadrant number 3, quadrant number 4. Any point on this Cartesian system will have 2 values, a value for x and a value for y. In order to locate a point, we need to have a value for x and a value for y. as you can see on this graph, for example, that point 3 and 5, it means it has the value of x3. So you can see that, here. 1, 2, 3, and y is 5. 1, 2, 3, 4, 5. This is 6 and 0 because it's on the x-axis. No value for y. This is 0 minus 5. The x is 0 because it's on y-axis. Okay. Turn on the air conditioning.
That's kind of odd.
Okay. Then we have, when we have two quantities, they can be expressed as an equation, like y is equal 4 minus x2. Here we say y is a function of x. Why do we say that? Because if the value of x changes, if I put different numbers for x, I get different values for y. So we say either y, or we can say f, sign of a function, f of x is equal to 4 minus x2. And in order to graph an equation in two variable, you need to have 2 points. This is one method for graphing such equation, point plotting method. Let's look at some of these examples on page 374. Example 4, for example, it has, for A, it says f of 4 or fx is equal, for fx is equal 2x plus 3. What does it say? It means for this function, find the value for y when x is 4. So you just plug in 4 instead of x, and you find the value is 11. Okay? 4 times 2, 8, plus 3 is 11. Very simple, basically. Let's look at page 372, 73, an example of plotting. You can see, for example, it has at the top of example number 2, graph y equal 4 minus x2. So just write a column for x, write a column for y. Give different value for x, you find different value for y. If x is minus 3, y would be minus 5. So one of my point is minus 3 minus 5. So I go on the Cartesian system on the graph, I find the point with x be minus 3 and y be minus 5. And I find other points, probably you only need to have 4 points, 4, 5, 6, they put 6 points here. Yeah, 6 points would be fine. And when you do that, then you connect these dots and you have graphed that function. Okay? Let's look at example 3. That's a good one. That's a very practical one. It talks about the toll for a bridge costs $2.50. But if the commuter uses bridge frequently, they can have an option of purchasing a monthly discount pass for $21. But with the discount pass, the toll is reduced to $1. They still have to pay $1. So we want to see, well, is it really, how can this pass saves us money? So you have two equations actually. One function is this: y, the money that you pay for your pass, is 2.5 $2.50 times the number of times in a month that you use that bridge. Okay? You see that on that table? Okay. So if I don't use it, I pay 0. X is 0, Y is 0. If I use it twice in a month, then I pay $5 a month. So X is 2, Y is 5. And goes on, 4, 10, 12, 14, 16. So I plot all these points. That's that blue line on that graph. Now, the other function is this. You must buy a monthly pass of $21, but you still pay $1 for each time you use the bridge.
Right.
So it's 21 plus 1x. X is the number of times that you use the bridge in both equations. So again, use the same number, you get different values. Now, when you draw these two lines, the interesting point is this. These two lines intersect at the point 1435. What does it mean? It means that only when you use the bridge more than 14 times, you will save money. Because you see, up to that 14, if you can see, in fact, it's cheaper. If you use the bridge only 14 times a month or less, it's cheaper, don't buy a pass. But if you're using it every day or at least 14 and more than 14, then that yellow line is cost less. Do you follow me? Okay. The bridge is used 14 times in a month. The total monthly cost without the discount pass is the same as total monthly cost with a discount pass, mainly $35. But only when I use that more than 14 times, when I use it 16 times or 20 times or whatever, then it is cheaper to have a monthly pass. So it's not always having a pass saves you money. Okay, example 6, page 376. Okay, now here, again, if you go graphing functions, example 6 on page 376, at the bottom of page 376, we have two functions. The first one is f is equal to 2, f of x is 2x. Second one, g of x is 2x plus 4. Again, I have two columns, one for x, one for f of x or y. Plugging values in x. If x is -2, f of x would be -4. If it's -1, then would be y would be -2 because it just multiplies by 2. If it's 0, it's 0, and so on. G of x, the same thing. You put different value for x, you find the values for y or g of x. You draw those two lines by, just finding those points and connecting them together. Okay. Yeah. Their slopes are the same. Linear function and their graph, all equations of the form ax plus by equal to c are straight line because the exponents are 1. If the exponent was anything other than 1, it would not be linear. It will have some curvature. These are called linear because the exponents are 1. The x-coordinate of the point is where the graph intersects the x-axis. The y-coordinate is where it intersects the y-axis. In order to find them, just put 0 for y, you find the x-intercept. Put the 0 for x, you find the y-intercept. Slope is very important for drawing, graphing. Slope basically means rise over run, changing the y over changing the x for two different pair of points. In other words, for a slope, the changing y would be y2 minus y1 over x2 minus x1. Okay, you follow me? Okay. if I have 2 points, let me. Stop share. Okay. Slope is change in the y. I call that delta y over delta x. Rise because y is a vertical axis, over run because x is a horizontal axis. If I have 2 points, let's say x1 and y1, and x2 and y2. These are 2 different points, true? Okay. Okay. So the value of y2 is different than y1. Yeah. So the slope would be change in the y, y2 minus y1, over the change over x, x2 minus x1. If, for example, I had 2 points, 3 and 5, and another point, 2 and 7, what would be the slope of this line? M would be the change in the line, 7 minus 5, change in the x, 2 minus 3. I get 2 over minus 1, I get minus 2. The negative tells me this line is going this way, going downward. Change in the y over change in the x. Okay. Follow? Yes. All right. Okay. No problem. Okay. And when we have a y-intercept would be, okay, let me explain this. Let's go here. You got to know this formula. Y is equal mx plus b. M is a slope. Okay? Slope intercept of the equation of a non-vertical line with a slope m, and y-intercept is this. Now that, you see, as you can see here in the PowerPoint, this is rise, this is run. The difference between y2 minus y1 over x2 minus x1 gives you the slope. Okay? Depending if it's positive, it's going upward. If it's negative, it's going downward. But the function, when you have slope-intercept equation is this, when you have y is equal slope times x plus b, and b is the y-intercept. B is a point when this line intercepts the x-axis. Okay?
Right. Okay.
Yeah, y-intercept is when it intercepts the, did I say x-axis?
Yeah.
The y-axis. Okay. And if it's positive, it goes up. If it's negative, it goes down. Okay. Now, graphing y mx plus b using a slope and y-intercept, plot the points containing the y-intercept on the y-axis. The point that where x is 0 and you have the b. Obtain the second point using the slope. Write that m as a fraction. Use a straight edge to draw the line. Basically, let's look at some example. That's the easiest way to, instead of reading it. Let's go to page 388. Let's look at page 387 for a moment. Example 3. It gives you y is equal 2 over 3x plus 2. 2 over 3 is your slope, and it's positive. The 2 is the y-intercept. It means the point where that line cuts the y-axis.
Okay.
You see that graph on page 352, 387, yeah. Graph 7.21? Mm-hmm. You see, the y-intercept is 2.2 on the y-axis. The x is 0.
Right.
Is that clear? Yes. So that's the b. Now, if you want to draw this line without doing any of those plug-in, you know, x, y, I know the slope. The slope is 2 over 3. 2 is what? The change in y. Rise over run. It means if I go from that point, the y-intercept, if I go 2 points up, I get to 0.4. And if I go 3 points toward the right, because it's positive, I get my second point. And I just have to connect those 2 dots together. You see that? So I don't need to put different value. All I have to do, I find the point 2 on the y-axis, then I know if from that point, I go 2 points up and 3 points toward right. The change it, rise over run. I got my second point, I connect. Yeah. Now let's look at those examples, like example 388. Okay, we have 2x plus 5y equal to 0. All right, we want to change it to that formula, to y equal, let me write it. Okay, we have 2x plus 5y equal to 0. Yes?
Yes.
Our equation was this. This is the shape of equation we want to have. Y is equal to mx plus b. Yes?
Right.
What was m?
The slope.
What was b?
The intersection.
Y-intercept.
The
Okay.
Y-intercept.
So I have to change this to this form. So what do? I minus 2x for both sides. Mm-hmm. So these two cancel. I get 5y is equal to minus 2x. Okay? Divide both sides by 5 to get y is equal to minus 2 over 5x plus what? 0.
Oh, 0.
Okay? So, what's my slope?
Minus 2
over 5. What's my y-intercept?
0.
What does this negative sign tell me?
It's going down.
Going down. So if I want to draw it,
No.
You don't.
No.
Oh, yeah. Sometimes they do. You don't.
Is that working?
Yeah, it's awesome.
Yeah, that one doesn't work at all.
Great. Let me check this. Let's see. If I have, okay, that's good. This is y-axis, this is x-axis. What does this 0 tell me? The point that intersect The y-axis is 0, right here. Now, from there, it tells me, go 2 points down. Why down? Negative 1 and 2. And then go 5 points left or right?
Right.
Right, because it's positive. So 1, 2, 3, 4, 5, it'll be here. So my line will look like this. Going down. Okay? So you see, with that easily, I could draw the line. Just I didn't need to put all different values for x and y, just with the slope and y-intercept. Nice. Okay. All right. Solving linear system by graphing. The solution to a system of linear equation can be found by graphing both of the equation in the same rectangular coordinate. Where they intersect is the solution. When those two linear equations, if I have two equations and I draw two lines, where those two lines intercept, that's the solution. Look at example 2.3, page 395. Okay, I have two equations. The first one is example number 2, page 395. X plus 2y is equal to 2. The second one, x minus 2y is equal to 6. When I solve these two equations, that means I want x plus 2y equal to 2. I said y equal to, if y is 0, x is 2. If x is 0, y is 1. No, wait a minute. Yeah. No, x. Yeah. Yeah. So I find if x is 0, y is 2. If x is 2, y is 0. If x is 0, y is 1. Okay? Then I graph that. That's just for the first equation. You follow me?
Yes.
Okay. Then I go to the second equation, x minus 2y equal to 6. Again, I find the point x that cuts the x-axis. I put y equal to 0, x is 6. Then I want to find the y-intercept. I make x equal to 0. Then y is minus 3. So I find 2 points, 6 and 0, and 0 minus 3. I draw those two lines. I connect those 2 points. I draw the second line. You follow me? If you look at the figure 7.28. All right? You see that? Yeah. Okay. Where do they intersect? At the point 4 minus 1. The point that x is plus 4, y is minus 1. That's the solution for this equation. It means for that point, both of these equations are true. If you put 4 minus 1 in either of them, it will be true. You follow me? All right. Okay. Solving a linear equation by adding is, again, if necessary, rewrite both equations, multiply, add the equation in step 2, and solve the equation in one variable, back substitute. Let's again look at an example in order to make it more clear. Let's look at page 399. You have 3x plus 2y equal to 48. 9x minus 9y equal to minus 24. You see, in the previous method, we find the x-intercept and the y-intercept for each of those equations, and then we draw them, and then we find the intercept, and that was the solution. Now here, we are not going to draw. We are going to solve this equation by addition and subtraction. I have 3x plus 2y equal 48, 9x minus 8y equal to 24. If I add them together, I get, let's see, actually, in other words, we want to eliminate one of the variables. So you multiply this first one by minus 3, it becomes minus 9x minus 6y minus 144. Then you add these two equations together, those x's cancels out, so you get minus 4y equal to minus 168, y is 12. Then you take that 12, put it in either of those equations. You got the answer. You get the x. X is 8. Therefore, for x equal to 8, y equal to 12, both these equations are true. Same situation continues.
So just to make sure, so a proposed solution A and 12 is where they intersect? Or what?
Yeah. But we find that without drawing the graph. Exactly. Very good. Graph. Oh, wait a minute. Where do you go? Graphing linear inequalities in two variables. Now, let's say we have inequalities with two variables. I think the best way to do it is just look at an example. You can read the PowerPoint, but I want to go over an example that makes it much more easier. Let's go to page 409. All right. We have this inequality of 3x minus 5y, example number 1, greater than or equal to 5. I'm sorry, equal to 15. So, first of all, it says, just replace that inequality with the equal sign, because I'm not changing, I'm not dividing or multiplying by negative number. Just assume that instead of inequality is plus, is equal sign. All right? Find the x-intercept, find the y-intercept. The x-intercept, it means y is equal to 0. If I put 0 for y, x would be 5. The y-intercept, x is 0. If I put 0 for x, y would be minus 3. So I find the line will pass through 0 minus 3. Okay? Then the point, okay, 0 minus 3. Then we choose a test point to find out which side of this line are we talking about. For example, if I choose the reference, choose the point 0, 0. If I put 0, 0 in this inequality, I get 0 greater than equal to 15, so it's not true. So the graph is all the points to the left below that line. Let me do it on the board to make it clear. All right. What's our inequality? 3x minus 5y. It's greater than equal to 15. Okay?
Yes.
So the first thing I did, I said, let's assume this is the equal sign. So I've made 3x minus 5y equal to 15. Okay?
Yes.
Then I say find the y-intercept. It's a point where x is 0. If x is 0, or let's do first the x-intercept. The y is 0. If y is 0, then we have 3x This is 0 equal to 15, x is 5. Yes?
Yes.
Then I say, let's find x-intercept. X-intercept, the y-intercept. X is 0. Yes?
Yes.
So I get minus 5y equal to 15. Y is equal to minus 3. So I find my point. My point is 5 minus 3. If I draw the Cartesian system, the x-axis and the y-axis, this is the reference, which is 0, 0. I have x equal to 5. 1, 2, 3, 4, 5. Y is minus 3. 1, 2, 3. So my point is here. This line goes through this. It's a straight line. Okay? That goes through this, and and you can find it. So you find 0 minus. No, what am I doing? I also have this point. No, I'm sorry. I got confused. If y is 0, x is 5.
Yes.
If x is 0, y is minus 3. I'm sorry, forget what I just said. So if x is 5, for x5, y is 0. So this is one of my points. All right? Okay? My other point would be x is 0, y is minus 3. So this is my line. Okay? Now, remember this was an inequality. So we want all the numbers greater than or equal to 15, which makes this inequality true. I need to know which side. Am I talking about here or am I talking about here? I pick a test point. I make a test. Just check it. If I pick here, this easiest one,
Right.
the reference 0, 0. If x is 0, y is 0, I end up 0 here. I'm saying 0 is greater than or equal to 15, which is not true. Okay? So these numbers cannot be on this side. It doesn't matter. I don't need to pick any other number.
It goes all the way.
Yeah, because if it's true, if it was that side, it must have included that point.
Oh, okay.
It doesn't, so it means all the points here. All the points here. For any point below this line, if the point is y, let's say it's y minus 6, x is 5. If I have 5 minus 6, that would be true. Let's check it. If x is 5, this would be 15. And y is minus 6, so minus times minus plus, 6 times 5, 30, so I get 45. Yes, 45 is greater than 50.
Okay.
You see my point?
Yes.
And I don't need to check more than one test point, because if this was over there, it must include this.
Okay.
But if I put 0, it doesn't hold.
I see.
All right. Be clear?
Yes.
Okay.
And so would you conclude that using deductive or inductive reasoning, if you use the 0?
Because it must be true for all the numbers. When I say it fails for 0, I'm using inductive. I'm making one test point but I'm going from, you see, this is a scientific analysis. You go from inductive to deductive. You test and you make general statement. That's a very good point. All right. I think. But look at just on page 413. Here you have two equations, two inequalities. Again, solve each of them. You know, x minus y less than 1, 2x plus 3y greater than or equal to 12. Make those inequalities to an equal sign, solve each of them, and then find 2 points, meaning finding 2 points that you will find the x-intercept and the y-intercept for each of those. Draw those lines, but when you draw the line, look at the graphs at the bottom of page 413. The first line is that blue line, x minus 1, y equal less than 1. And it's printed with the dotted dashes because it's not equal. You see that? Yeah. The other one is solid. Now, we want to find a place where these things hold. We find a test point. We find the test point for the first line. You know, I put the reference 0, 0 in the first equation. It says if I put 0, 0 in the first equation, I get 0 equal to 1, which fails. So let me see. No. Okay, because 0, 0 makes the inequality true. Oh, yeah. 0 is less than 1. Yeah, you know. So that no, it doesn't fail. That's true. So it includes the reference point. So you get all the lines above that dashed line. Right. Now, I go to the second line, that brown, solid brown line, and I put the reference point 0, 0. I always use that, the textbook use that because it's the easiest. Sure. But when you put the 0, 0, it fails because if I put 0, 0, I get 0 greater than or equal to 12, which is not true. Yes? Yes. Okay. So it cannot include the reference point. So it must be the whole area above that brown line. Right. So the solution for both these inequalities, for this system, they call it a system of inequality, would be the area that both intersect, the area which is common, overlaps for both of them, which would be that section, that part. All right? Is that clear? All right, let's continue. We have exponential. When you want to graph exponential, you have y equal b to power of x, or f of x to b to power of x. B is a positive constant, not equal to 0 and greater than, not equal to 1 and greater than 0. Again, an example for that would be page 423. Again, you can see that you have f of x equal to 2 power of x. You just plug in different value for x, you get different value for y. And because you see the exponent is more than 1, you get a curvature. And you connect those dots. All right? Let's move on. Logarithmic. Definition of logarithmic function. Basically, this is a logarithmic function. F of x it's a reverse of exponential. or they are equal actually, but they are expressed in different forms, different ways. F of x equal to log base b of x, where x is greater than 0 and b is greater than 0 and b is not 1. In other words, y log b of x is the same as b to power of y equal to x. You just got to memorize those equations. The first one, the y log b of x, is a logarithmic form. The second one, b to power of y equal to x, is an exponential form. All right? You follow me? The first one is logarithmic form. The second one is exponential. All right? To graph logarithmic functions, let's go to page 427. We have the logarithmic form. For example, example number 4, y equal to log 2 of x. Log 2 of x means it's the same as 2 to the power of y equal to x. So just give different value to y, you find different value for x. Okay, you follow? Because log 2 of x is the same as 2 to power of y equal to x. You got to memorize those two equations. Y log b of x is b to power of y equal to x. When you put different value for y, you get different value for x, you draw the line. All right? Let's go. We're almost done. Graphing quadratic function, it always gives us a parabola. When we have ax2 plus bx plus c, f of x, when you graph it, you get a parabola. And depending if a is greater than 0, the parabola will be upward. If a is less than 0, the parabola will be downward. The x-coordinate is b over 2a negative. So again, we find the x-intercept, we find the y-intercept, and we find the vortex and connect them. Find 3 points, and depending whether a is plus or negative, it goes either upward or downward.
What's the vertex?
It's that either the lowest or the highest point. Let's look at the example to make it clear. Go to page 430. Okay, for example, you see that graph figure 7.54. The vertex here, because a is negative, a is positive, it goes upward. The vertex is the lowest point. Page 431.
Oh, that's right.
Okay. The vertex is the lowest point. If the a was negative, the vertex would be the highest point. It would be up. Actually facing down, but the vertex would be the highest point. So to graph it, example 6, they give us the function. It's a quadratic function. Y is equal x2 minus 2x minus 3. We find a, b, and c. A is 1, b is minus 2, c is minus 3. Vertex is minus b over 2a. When you plug in the number, the vertex is plus 1. So it has to be plus 1. And then we know that's the point, but we need to find both the, we find the x for the vertex. We want to find the y for the vertex. If we put 1 in that, put 1 back in that original equation, you get y equal to minus 4. So if we find our first point, the vertex is 1 and minus 4. You follow me?
Yes, the vertex is 1. Yeah.
Okay. You got x of the vertex by that formula, minus b over 2a. Once you find the x, just plug it in, you find the y. So you can locate the vertex on the graph. Then you solve that quadratic equation. That's where all those factoring and quadratic formula that we talked about come handy. You write that into two parentheses. The x and x, one should have x minus 3, one x plus 1. And you solve these two parentheses, you get x is equal to 3 or x is equal to minus 1. So we plug in the x, or actually it tells us when it's giving us the y-intercepts or the x-intercepts. It tells us this graph on 2 points cuts the y-x-axis at point 3 and point minus 1. So now I have 3 points. I have my vertex, I have my one of my x-intercepts, and I have another x-intercept. So I just connect them, and because A is positive, I know this parabola should go upward, face upward. All right? We are done. I know this was lots of information for one session, algebra and graphing. Any question anywhere is not clear for you? Or the online student, please, if anywhere not clear, email me, send me an email. Or on the board, you can send me a message. All right? Okay, then let's finish. Let's have a prayer. Father God, we thank you that by your grace we were able to finish this session too. I know there are lots of information. I just pray that you help all the students to be able to digest and comprehend all these materials and do an excellent job in all their quizzes, homework, assignments, everything. Bless each one, and may they not be discouraged and move forward and work harder and harder, and everybody could get good grades and learn the concepts that are presented in this class. For in Jesus' mighty name we pray. Amen. All right, let me stop the recording. And